Any organic material present on this earth is used and reused again and again. For example, in a forest ecosystem, plants produce organic material or nutrients using the sun's energy, which is passed on to herbivores when they consume plants. The herbivores in turn are consumed by carnivores, and in this process, the organic matter is passed along to various animals. When these animals die, the organic material from each of them is made available to plants by decomposers. Therefore, organic matter or nutrients are never lost from an ecosystem, but are recycled over and over indefinitely. This cyclic movement of nutrient elements between organisms and the environment is known as nutrient cycling or biogeochemical cycles. Here, bio refers to living organisms and geo refers to water, rocks, air and soil on the earth, and chemical refers to nutrients such as carbon, phosphorus, calcium and iron, to name a few. Now, nutrient cycles are of two types, gaseous and sedimentary. In gaseous cycles, the atmosphere is the main reservoir of nutrients, whereas in sedimentary cycles, soil, rocks and minerals of the Earth's crust are the main reservoir of nutrients. Reservoirs serve to replenish nutrients in case of any imbalance arising out of variations in the rate of influx and efflux in the biosphere. The rate of release of nutrients into the atmosphere in both gaseous and sedimentary cycles is regulated by biotic factors or living organisms, as well as abiotic factors such as soil, temperature, moisture and pH. At any given time, the amount of nutrients such as nitrogen, phosphorus, calcium and carbon in soil is known as standing state. There are several important nutrient cycles that sustain life on Earth. Nitrogen, oxygen, carbon and water are some of the important gaseous cycles, while phosphorus, calcium and iron are some of the important sedimentary cycles. Let's learn in detail about the carbon and the phosphorus cycle. The carbon cycle is an important gaseous cycle. In fact, carbon is the fourth most abundant element in the universe and the principal constituent of all living organisms on Earth. It constitutes 49% of dry weight of organisms and forms one of the major components in living organisms other than water. The carbon cycle describes the movement of carbon in its many forms between the atmosphere, land, water, and living and dead organisms. About 71% of global carbon is found dissolved in oceans, while just 1% is found in the atmosphere. The amount of carbon dioxide in the atmosphere is regulated by the oceanic reservoir of carbon. Another reservoir of carbon is fossil fuels. Also, a large amount of carbon is contributed to the atmosphere in the form of carbon dioxide during respiration by producers and consumers. Decomposers are also major contributors to the carbon pool. They break down waste materials and dead organic matter and return carbon to the atmosphere in the form of carbon dioxide. Natural events like forest fires and volcanic activities also release carbon dioxide. Apart from these sources, human activities like burning of wood and fossil fuels and rapid deforestation has also led to a marked increase in the amount of carbon in the atmosphere. Thereby affecting the carbon cycle and leading to the greenhouse effect. Have you ever wondered how this carbon cycle works? It starts with the process of photosynthesis, where green plants fix atmospheric carbon dioxide into organic compounds. Now, carbon in these plants is passed on to herbivores and then to carnivores. When these living organisms, including plants, respire, carbon dioxide is released into the atmosphere. Similarly, after animals die and decay, carbon dioxide is released into the atmosphere by the action of decomposers. Furthermore, the carbon in some dead organic matter is eliminated from active circulation as it remains buried, forming sediments, which, with the passage of time, form fossil fuels like coal, petroleum, and natural gas, and these too, when burnt, release carbon dioxide back into the atmosphere. Once again, the carbon dioxide present in the atmosphere is used by plants during the process of photosynthesis, thereby completing the carbon cycle. Like carbon, phosphorus also plays a very important role in the living world. It is a major constituent of the cell membrane, nucleic acid, teeth, bones, and cellular energy transfer systems in all living organisms. Now, let's understand the working of the phosphorus cycle, whose natural reservoirs happen to be rocks, which contain this nutrient in the form of phosphates. When rocks weather, small amounts of phosphates dissolve into the soil and is absorbed by plants. The phosphates then get passed on to animals when they consume plants. Once these animals die, phosphate solubilizing bacteria act on their bodies and release phosphates into the soil, thereby completing the phosphorus cycle. However, unlike the release of carbon into the atmosphere in the carbon cycle, There is no release of phosphorus into the atmosphere in the phosphorus cycle. Furthermore, inputs of phosphorus through rainfall are much less than that of carbon. Also, unlike in the carbon cycle, there is very little gaseous exchange of phosphorus between living organisms and the environment in the phosphorus cycle. However, the phosphorus cycle, along with other nutrient cycles, play a very important role in maintaining healthy ecosystems. Healthy and functioning ecosystems offer us a wide range of products and services known as ecosystem services. Some of the products provided by a healthy ecosystem include fruit, pure drinking water, food crops, spices, fiber, energy, and medicinal plants, among other things. A healthy ecosystem also provides us services or performs functions such as purifying water and air, maintaining soil fertility and wildlife habitats, pollination, nutrient cycling, mitigating floods and drought, and providing storage sites for carbon. However, it is difficult to assess the value of these different products and services provided by an ecosystem. But today, researchers like Robert Constanza and his colleagues are trying to assess the value of the different ecosystems, which are otherwise taken for granted as they are available freely. Researchers have found that the value of fundamental ecosystems is an average $33 trillion a year. Of the total cost of different ecosystem services, 50% is accounted for by soil, less than 10% each by services such as nutrient cycling and recreation, and about 6% each by services like wildlife habitat and climate regulation. Thus, our ecosystems are of great value. However, their services and products are limited, and so efforts must be taken to preserve natural ecosystems for the sustenance of human life.